So in this episode of Mrs. M's Math for the Masses, we're going to work on Pythagorean theorem. We've done it previously on the coordinate plane when we found the length of a sloped line. But here we're looking at three right triangles. We know they're right triangles because the perpendicular symbol marking that two meet at a right angle. The most important thing for you to remember will be that the longest side of a right triangle has to be the side across from the right angle because it's the largest angle. So this is called our hypotenuse, but in our formula it's going to be C. Okay, so you can do that right now. Find the C of each of these scenarios. Okay, so now you want to do your A and B, and it does not matter which of the other two you call A or B. It just matters that C is by itself on one side of the equal sign. So we'll put our 10 squared to represent the 10 in the C position being squared. We'll do our 6 squared plus x squared. 6 squared is 36. 10 squared is 100. So let's get all our like terms, these values, to one side. And we have x squared equals 64. The opposite of a square is a square root, so x equals 8. Pythagorean theorem is great because you can check your work. For something like this with whole numbers, where all three sides are represented by a whole number, we learned in the fall. That's called a Pythagorean triple. And I told you, go to the YouTube channel and make sure you find Triangle Man who sings a Pythagorean triple song he made up, so you know all the combinations. But here, if we want to check our work, we could say 6 squared plus 8 squared equals 10 squared, and we would get 36 plus 64 equals 100, and 100 does equal 100. Every one of these examples you should check. Make sure you use as many of the decimal places as possible. If everything is rounded to the 10th position, you will not get as close as you will if you use all the decimal places. Let's try our next example. We can say our C is 7.3. We're going to square it. Y squared plus 2 squared. Okay, so when we square 7.3, we get 53.29. 2 squared is 4. There's our y squared. Let's move our 4 to the other side, and we get y squared equals 49.29. The opposite of a square is a square root, and we get y equals 7.02068. So when you go back to do a squared plus b squared equals c squared to check your work, use all of those decimal places, and that will give you the best result. Let's try one more example over here where we said C was 16. So we're going to say 16 squared equals z squared plus 4 squared. 4 squared is 16. 16 squared is 256. And here's z squared. Let's move our 16 to the other side. Z squared equals 240, and your decimal answer C will be equal to 15.4919. Now remember, we learned how to do simple radical form by dividing into the number with prime numbers. So 2 goes into 240, gives you 120. 2 goes into 20, gives you 60. 2 goes into 60, gives you 30. 2 goes into 30, gives you 15. 5 goes into 15 and gives you 3. 3 goes into 15. You have to get to the one and done. So we practiced in the fall. For every pair of numbers, one comes out of the radical, anything that's not paired has to stay inside the radical. And what do we say after 2 become 1 and move out? They multiply. 2 times 2 is 4. Square root of 5 times square root of 3 is square root of 15. In your calculator, do 4 times the square root of 15, and the decimal will be 15.4919. There's some examples of Pythagorean theorem.